Okay, now let's discuss the practice exam for the third exam. The first one. Okay, so today is the first problem. We have the function f(x) square root of x, gx 2x minus 1, hx x squared, and 1. Evaluate f circle g of 5. Okay, then by definition, it is f of g of 5. So g of 5, you follow this formula. So it's, I'm sorry, f. 5 times 2, 10. 10 minus 1, 9. F of 9 here is square root of 9 is 3. Second, h of g of f of 9. Okay, f of 9, you need to use f function. Square root of 9, square root of 9 is 3. G of 3 is 2 times, see here, 2 times 3, 6, 6 minus 1, 5. H of 5 is 25, 5 squared. Okay, so that's our first problem. Second, fx is 1 over x plus 2. Gx is 4 over x minus 1. Find the composite function under the domain. F compose g of x. So f compose g of x is f of g of x. And here, g of x is 4 over x minus 1. So it's f of 4 over x minus 1. So continue plug in. So it's 1 over. So you apply f function. So 1 over x. You see x is 4 over x minus 1 and plus 2. Then the rest part is a simplification. Okay, so this is a formula. And what is the domain? First, you have g of x. So g of x gives you x is not equal to 1. You have f of 4 over x minus 1. So f implies this input is not equal to negative 2. So 4 over x minus 1 is not equal to negative 2. Not equal to negative 2. Then let's compute what is the condition. 4 over x minus 1 is equal to negative 2. Then what you get? You get 4 equal to negative 2x plus 2. So negative 2x equal to positive 2. X is negative 1. So x cannot be negative 1. So you just put a negative sign next. So x cannot be 1, x cannot be negative 1. So put things together. So it's all x. X is not plus or minus 1. Okay, so this is the domain. This This is the domain. Okay, so you get the first condition from G, internal one, and second condition from F, the external one. And to get the removed point from external one, you just first solve the equation. So you do the multiplication and try to compute it. Okay, so this is A. B is the following. G of f of x. G of f of x is G of f of x. F of x is 1 over x plus 2. So it's G of 1 over x plus 2. And then you apply the g function. So it is equal to 4 over 1 over x plus 2 and minus 1. So it's x plus 2 negative x minus 1. Okay, so this is a formula of G circle F. And domain, what is the domain? Let's see. You have fx. You have fx. It implies x is not equal to negative 2. Right? Fx. In order to make fx well defined, x is not negative 2. And then you have g of 1 over x plus 2. So it implies 1 over x plus 2 is not equal to 1. You see, you have to make sure this denominator is not 0. So 1 over x plus 2 is not equal to 1. Let's solve it. You multiply two sides by x plus 2. And you move 2 to the other side. So x is not equal to negative 1. So x is not equal to negative 2, x is not equal to negative 1. Combine these two things together. So it's a set of all real numbers except negative 1, negative 2. Okay, so that's the second problem. And problem 3, find the inverse of the function. Find the inverse of the function. So you put this y. So y is square root of x plus 2 minus 3. We're going to solve x in terms of y. So move 3 to the other side. Square two sides. And move the 2 to the other side. Okay, so up to this step, this is still the original equation, original function. Exchange x and y. So the inverse function is this one. Y equal to x plus 3 squared minus 2. Okay? So this is the inverse function. Solve x in terms of y and then exchange x and y. Problem 4. Assume this f is given by -1, 5, 0, 0, and 2, 6. First, find the inverse. What is the inverse? The inverse, you just exchange x and y. So this formula just means when x is -1, y is 5. X is 0, y is 0. X is 2, y is 6. So f inverse, if we want to have such thing, then f inverse, you just exchange each pair x, y position Okay, so this is a F inverse. F inverse of 5. F inverse of 5. F inverse of 5. Read it here. F inverse 1. When you have 5, the output is -1. So F inverse of 5 is -1. C. F inverse circle with F. We know that the inverse composed with the original function is identity. So F inverse composed with F evaluate at 2 is equal to 2. So you don't have to do any computation because number 2 is in the domain, so you can have it. Okay, that's it. Number 5, find the vertex and the symmetric axis. So of this parabola fx is negative 2x squared minus 4x plus 2 plus 3. Okay, so this is a complete square process. So we have first you factor out the coefficient of x squared. Leave 3 outside. And then here you see, remember we have x squared plus 2ax plus a squared is equal to x plus a squared. So this is a formula, complete square formula. Here you have x squared plus 2ax, so a is equal to 1. In this case, you see that a is equal to 1. But you don't have this 1 squared, so you add 1 squared. 1 squared is still 1. And you here you add a 1 squared. Technically, this 1 is multiplied by -2. You add it, you're going to minus it. You see, here you add 1 times -2, so you're going to minus 1 times -2. And this part, -2 times 1 is -2, minus -2 plus 2, so it's 5. Okay, and then from here we can read the vertex. The vertex is, be careful, vertex is -1, 5. The vertex is -1, 5. In the vertex formula, the vertex formula is, here's minus, here's plus, x minus h squared and plus k, a times it. So here a is negative, so it's x minus 1, so it's a plus, it's a x minus -1, so it's a -1 and 5. That's vertex. And the symmetric axis is x equal to -1. Whenever you see the x coordinate, it will give you the symmetric axis. Okay, so that's problem 5. Problem 6, find or form a polynomial with real zeros and degrees. So the zeros, you have -1 multiplicity 1, 0.3 multiplicity 2, and degree 3. Okay, so when you have this -1 as 0, so you have x minus -1. The multiplicity is 1, so you just have one factor. 0, 3 means x minus 3 is a factor. Multiplicity 2 means the power is 2. And you have 1x, here you have 2x, so the total degree is already 3, so you don't need any extra factor, so the fx is equal to it. We just need 1, so you don't have to put a coefficient. Just leave the coefficient as positive 1, that's it. So this is the final answer. Seven, find all the asymptotes. Here, all the asymptotes means horizontal, vertical, or possibly slant or oblique. If it has, you just find it. If there's no one of the asymptote, don't worry. Okay, so first of all, let's factor the numerator. If we factor the numerator, what we have, it's okay, so factor 2 as 2 times 1, negative 5 as 5 times negative 1. So you do the cross multiplication, you get this product is 5, this product is negative 2. The sum is a positive 3, exactly. Okay, so the factor is 2x plus 5, x minus 1 over x plus 2. Okay, so nothing can be can be cancelled. This is the lowest form term, lowest term. Now then the vertical asymptote. The vertical asymptote is the denominator equal to 0. The vertical asymptote is denominator equal to 0. If some term can be cancelled, then that corresponding term does not give you the vertical asymptote. Now let's try to find the horizontal or slant asymptote, oblique asymptote. To do that, this process is used to determine the vertical asymptote. To determine the horizontal or oblique asymptote, you need the long division. So divide leading term by leading term, you get 2x. And then you do subtraction. And then divide the leading term by leading term, you get a negative 1. This term is divided by x, you get a negative 1. Negative 3. Okay, so now this degree is less than degree x plus 2. So the function fx is equal to 2x minus 1 plus negative 3 over x plus 2. So denominator is still denominator. The quotient is placed here. The remainder is placed here. And it's always addition. Because this quotient is a linear function, so the line, we have the oblique asymptote. Is y equal to 2x minus 1, just this term. Okay? So that's the solution of the solution number 7. Eight, mathematical induction. Mathematical induction is the following. The statement depends on the integer n. So we will first examine the statement for the smallest integer. So first, when n is equal to 1, when n is equal to 1, the left-hand side is what? It's just 1. You know that the left-hand side is the sum of first integer. So when n is 1, you just have one integer 1. The right-hand side is what? Is a 1 times 1 plus 1 over 2. 1 plus 1 is 2. Cancel 2. You get 1. Okay, so the left hand side is equal to the right hand side. You have to separately compute them. So the statement is exempt. So we just check, verified, checked, exempt. Assume that for n equal to certain integer k, the statement is correct. So it means we already started the chain. The chain equal to 1 is okay. Now assume we already we have the case step of the chain. So for example, you have a chain of restaurant. You start the first restaurant. You already have k restaurants, right? So chain. Okay, so assume the statement is correct. What does it mean? It means if you add 1 up to k, it is equal to k times k plus 1 over 2. So that's what it means. The statement is correct. You have k restaurant. Let's talk about the next. For n equal to k plus 1. For n equal to k plus 1. You already have this. For n equal to k plus 1, let's check the left hand side. The left hand side. Left hand side is a sum of first n plus 1 integers. And remember, you already know the information about your first k restaurant, because that is the current situation. You already know it. The left hand side from 1 to k is equal to this. And then you add your next term, your next restaurant. You see here you have the common factor k plus 1. Factor k plus 1 is a k over 2 plus 1. And then this, if you write it, it is a k plus 2. So it's a k plus 1, k plus 2 over 2. The denominator 2 is here. Okay? So this is left hand side. It's a sum. And right hand side, when n is k plus 1, check that formula. When n is k plus 1, it's a k plus 1. It's n plus n times n plus 1 over 2. It's your expectation. N times n plus 1. N times n is k plus 1. N plus 1 is k plus 2 over 2. Right? This is your expectation. Your sum is equal to the expectation. So left hand side is equal to right hand side. Then what do you see? You already examined the first restaurant. You assume when you have k restaurant, the statement correct, and you do the reasonable deduction computation, you get for the next restaurant, you still can manage it very well. Then by the mathematical induction, for everything, for all the restaurant, 1 plus 2 plus 3 plus n is always n plus 1 over 2. So that's a mathematical induction. Let me see what. Oh, this is a 5. So mathematical induction always has 3 steps. First step and second step assume. Third step for the next one. For the next one, you always separately discuss a left hand side and right hand side and figure out they equal to each other. Then by the induction is correct. Okay. Okay, so this is a problem 8. Then problem 9. determine on what interval function is increasing, what interval function is decreasing. We have this function. This function is a polynomial. Is a quadratic parabola. Let's say it's a parabola. Parabola. You have vertex, you have the symmetric axis, and you have opening. Okay, so first let's try to sketch it. So what is the vertex? From this formula, you know that the vertex is -3, -3, 4, and it opens up because the coefficient is positive. Okay, so let's first get -3 and 4. And this is a symmetric axis. It opens up. It's very big. Okay, so it looks like this. You don't worry about how good or how bad your sketch. And from here, from this graph, it opens up. You can see that the function is decreasing on the interval -infinity to -3. Left hand side decreasing, increasing on -3 to +infinity. The right hand side is increasing, and that's it. Problem 10. List each real zeros and the multiplicities and determine whether the graph crosses or touches x-axis at each x-intersection. 2. Okay, so from this factorization, we know that zeros, we have 5 with multiplicity 3. Here you get a -4 with multiplicity 2. Okay, so just be careful about the second 0, it's a -4. And because the multiplicity is 3 at 5, the graph crosses at at odd multiplicity, the graph crosses x-axis. At even multiplicity, zeros, the graph touches x-axis. It's even, because it's even, so it will touch the x-axis. Okay, so this is a 10. 11. Let's see the 11. 11, we are going to sketch the graph of function (3 over x squared minus 4). Okay, so sketch it. First, domain. Domain, x squared minus 4 is not 0. So x is not plus minus 2. So domain, you have -infinity to -2, -2 to 0, 2, and 2 to +infinity. This is the domain. Okay, and when we have the domain, we will have a asymptote. Asymptotes x equal to 2, x equal to -2, right? And intercept, y-intercept. Y-intercept, x equal to 0. X is 0, it's -3 over 4. Y-intercept. X-intercept. X-intercept, 3 over x squared minus 4 equal to 0. No solution, no. So there's no x-intercept. Okay, and horizontal asymptote. Here is the vertical asymptote, horizontal asymptote. Because the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is y equal to 0. Okay, so we have almost all the information we need. Let's sketch it. Plus minus 2. Negative 3/4. Okay, and that's it. We only have 1 point. So we are going to just pick up sample point. If it's negative 3, it's negative 2, negative 1, 1, 3. And another thing you can check, this function is an even function. So if you know how to sketch it on the right hand side, you will know the sketch on the left hand side. So we check the value at 3. At 3, we need some point. F of 3 is what? 3 squared is 9. 9 minus 4 is 5. 3/5. So it's here. If you want, you can examine more. If you examine more, it will be more or less like this. Don't touch x-axis. There's no intersection. And here you examine x equal to 1. This is negative. Sorry, it's a 3/5. F of 1. F of 1. 1 squared is 1. Minus 4 is negative 3. 3 over negative 3 is negative 1. So it's like this. Okay, and that's it. That's a graph. That's a graph. So here, this part, if you don't know it, you're going to find more points. For example, 2.5, and you checked here, and 4, you checked here. You have 3, or you have more points. You can plot it better. Okay, so don't just save your time. You can, if you have enough time, just try more samples. For example, you try here, try more samples, and figure out the graph. When you get the right side, the left side is the same. Okay, so we finish the discussion of exam. So let me put them in the sequence again. So first, this is a first page. Okay, and it's the second one, second page. Third page. Oh, do I make? Sorry. I think my order is wrong. This is the second page. I just put the 6th page. What up? And this is the 3rd page. Okay. Page 4. Page 5. Page 6 was presented at the second page. And the last page 7. Okay, that's good. If you have a question, send email to me. Okay.